Okay guys, I'm trying something new. I'm going to try to do the notes this way. We'll see how it ends up working out. It's a very simple assignment tonight. It's not too challenging. It's all we're doing is we're going to be taking the derivative just like we've been doing in the past. We're just going to start calling it a differential. The reason why is because we're getting closer and closer to doing integration, which is what the whole rest of the year is going to be about. So what we're going to do is we're going to take the derivative of both sides with respect to x. And
UTC will be starting now. Thank you.
And then we're going to, after we do that, see right here, see how we have a y on this side now? Sometimes we have f of x. You can always replace f of x with y if it is there. If I take the derivative with respect to x of y, remember it's different. So you would do the derivative of y with respect to x. So that's going to be a new thing. Instead of writing y prime, we're now going to write dy dx. So that's new. Well, not really new, just kind of bringing up to the past. At the very end, you're going to have to get dy by itself because you want the derivative of y. So we're going to multiply both sides by dx to get dy by itself. Okay, so let's go ahead and let's get started on this first problem. So we have, hopefully you guys can see this, y equals negative x squared minus 3x minus 2. So I've got y equals negative 3x squared, sorry, not negative 3x squared, negative x squared minus 3x minus 2. And what I'm going to do is I'm going to go ahead and do the derivative. So dy dx equals negative 2x minus 3. That just goes away because it's a constant. And then that was the first step, take the derivative, and now all we're going to do is we're going to move this dx from the left to the right. It's being divided, so we're going to multiply. So my final answer would be dy equals negative 2x minus 3 dx. You can, if you want, put this in parentheses, or you can leave it without parentheses. You could do just dy equals negative 2x minus 3 dx. But that would be your answer. Let's do another one. Find the differential dy of the function y equals x cosine 7x. Here we have two things going on. We have LDF plus FDL. That's x is my first function. And then cosine of 7x is my last function. Within the last function, you also have a chain rule. So that's where we have to set u equal to 7x. If you rewrite this, cosine u, what's the derivative of cosine u? Remember, it's cosine, the derivative of cosine, which is negative sine, evaluated at u times u prime. Well, what's u prime? U prime is 7. I plug everything back in, negative sine 7x times 7. You bring that to the front. So my derivative of the last function ends up being negative 7 sine x at, I'm afraid I'm not in this shot anymore, so let me go over here. My derivative of my last ends up being negative 7 sine at 7x. So there's the derivative of the last. The derivative of the first is equal to 1. So now I'm going to go and I'm going to do LDF plus FDL. So dy dx equals the L, which is my last function, cosine 7x, the derivative of the first, which is just 1, plus my first function, x, times the derivative of the last. Well, negative 7 times x, I'm going to go ahead and put that in. So that would be minus 7x, right? That x is my first function. The negative 7 came from my derivative of the last. And I'm just going to put sine 7x. So there's the derivative. Now what I'm going to multiply both sides by dx. So I get dy equals cosine 7x minus 7x sine x, sine 7x, and then dx at the very end. And that would be it. Okay, here's the last problem. It's a u try. So I want you to go ahead and try it. Doing it this way, I'm not going to have the answer for you on the U-Try. You can show me tomorrow in class, and I'll tell you if it's right or wrong. And then the very last problem, I don't know if you guys can see it. Well, here. The U-Try is find the differential dy of the function y equals 2x raised to the 3/7. So try that problem on your own. When you get your answer, circle it. I'll go over it tomorrow, or when I'm going around and checking the notes, I'll tell you if you're right or wrong. And then down here, looking towards the future, see if I can pull this up. I can't get it up any higher. So looking towards the future, let me see if it's actually in the screen. Yeah, it is. All right, looking towards the very near future, what is my original equation? Let's call this the antiderivative. That's where we're going in chapter 4. So what was my original equation that would result in the following equation, the following differentials? Let me write it real big. If I had dy equals 8x minus 1 dx, I want to know what was the step before that. So if you guys can figure it out, I need to see work. I don't want you guys just to give me an answer. I want to see your work. I want to see your thought process. For those that get it right, might get something special. Who knows? So think about what did I have before that resulted in this differential. And then go ahead and do the U-Try, do the derivative, or find the differential of the function y equals 2x raised to the 3/7. Okay, so we'll see how this video works out. It's a short lesson. It's pretty simple, so that's why I chose this one. All right, thanks. Bye.